So this question is from the 2004 exam. It's a type 6. Type 6 I usually classify this way because it's got a differential equation that we're going to find a particular solution of, as well as a slope field. And most often the slope fields are worth 2 points, and then finding the particular solution is 5 or 6 points, which leaves 2 points or so for some other thing that you do in the question. So starting off, we want to do a slope field, and the way we calculate slopes is we pick a point. For example, this point right here is at 1, 3, and we plug that into the equation. 1 squared times 3 minus 1 gives you a slope of 2. So we draw a line that is roughly a slope of 2. And we can continue doing that for all of the coordinates, which would take a little bit of time if you were to write down every single coordinate. But that's essentially what needs to happen. That has a slope of 1. You can speed it along by analyzing the slope equation, like, oh, this slope will be 0 when y is 1. So at every single location where y is 1, I'll draw a slope of 0. Similarly, you could say, oh, when x is 0, the whole slope will be 0. So every spot where x is 0, I draw a slope of 0. And you can continue going through that, analyzing this. Every time y decrements by 1, the slope decreases a little bit. So slope of 2, slope of 1, slope of 0, slope of -1. You could look at the symmetry of this. Because this is x squared, changing the x value is not going to change the sign of the slope. So the slope of 2 is also a slope of 2 over here. The slope of 1 is also a slope of 1 over here. -1. So that's what the slope field looks like. It's worth 2 points. The first point comes from, do you have the 0 slopes correct? So basically, are all of these 0 slopes? That's your first point. Your second point comes from the rest of the slopes, and what they're going to be looking at is, are these slopes, these 4 slopes positive, and are these 2 slopes negative? Okay. I don't think they are going to go so far as to compare relative steepness, but they might. But that's typically how it is. Do you have the 0 slopes correct, and are the rest of them relatively accurate? Okay, part B. While the slope field in part A is drawn only at 12 points, it's defined at every point in the xy plane. Describe all points in the plane where the slopes are positive. So we want to find where the slopes are positive. Okay. X squared is always a positive number, or 0, and y minus 1 will be positive only when y is greater than 1. So the entire slope will be greater than 0 when y is greater than 1 and when x does not equal 0. So all of this area and all of this area. So pretty much most of quadrant 1 and quadrant 2. Okay. The spots that are excluded are x equals 0 because that would cause a 0 slope, and numbers smaller than 1 because that would cause a negative number times a positive number. Okay. This is worth 1 point, the description of where it's at. Moving on to part C, we're looking for the particular solution. So part C, we're going to take our separable differential equation and go through the process of separating the variables. So in the first stage, I'll divide y minus 1 to the left-hand side and multiply dx to the right-hand side. And this gives me the separation of the two variables. X is on the right. From there, I want to take the antiderivative of both sides. The antiderivative of 1 over u is ln of u. Please be mindful that we would have a constant out front if this term was anything other than a slope 1 linear equation. And that's a U substitution problem worth looking at on the side. The antiderivative of x squared is x cubed over 3, and then both sides will have a constant added to them, and I combine the constants from both sides onto the right-hand side. At this stage, what we want to do is find the value of c by plugging in the initial condition. And the initial condition is x equals 0, y equals 3. So ln of 3 minus 1 equals 0 cubed over 3 plus c. And we can see that c is ln of 2. And let's solve this for y. Okay, continuing to solve for y, we have to isolate this y, so we're going to exponentiate both sides. Absolute value of y minus 1 is e to the 1/3 x cubed plus ln of 2. That's all in the exponent. This ln of 2 and the e operate together to create e to the ln of 2, and the e and ln cancel out, and we get this expression here, 2e to the 1/3 x cubed. In removing the absolute value, because our initial condition was a positive y value, we're going to take the positive version, and then we can add 1 to both sides. This is worth 6 points. Your first point comes from correctly separating the variables. You get 2 points for the antiderivatives. You get 1 point for the constant of integration in that step. You get 1 point for considering the initial condition, and then 1 point for arriving at your final answer. Now, in the past in class, I've taken a different approach where I solved for y before plugging in the initial condition, and it doesn't matter which approach you take. My opinion is that if there's a natural log, it's probably easier to solve for y first, but I didn't take that approach this time, and it wasn't too bad. So that's your 6 points. Be sure to smash that like button, comment, subscribe, buy my merch. And be sure to click that bell to get notifications every time I post.